So, Alec Mikhail, the floor is yours.
Okay, thanks. Can you see and hear me? Okay, so hi, my name's Alec. I'm presenting today on sort of a thought experiment about extraversion and its interaction with social network structure. This is a project I started 3 years ago at the beginning of my PhD and dropped until last week, and I sort of revitalized all the code and fixed a lot of bugs, and hopefully it's intriguing for you. So extraversion. Okay, so I'm going to define extraversion as intuitively the number of hours per week a person desires to spend with others. You could transmute this into the number of meetings you're willing to schedule, or any sort of continuous valued attribute that exists on a social tie, where a person both wants some of it but doesn't want too much. That's the main idea. So each person in my network, well, I guess I'll keep going, and what extraversion is will be clear as I go. In my model, relationships are formed and dissolved through discrete acts. The time differences between these acts follow some continuous time, like an exponential distribution. And intuitively speaking, if somebody is experiencing more social interaction than they prefer, then they have some higher propensity to forget one of their. And if they have too little social interaction, say they have no friends or they have very few compared to what they want, then they'll go out and make new connections. And even more concretely, let's just consider 3 nodes. These 3 individuals have different preferences for how much time they want to spend with others. I've labeled them, so 5 hours, 2 hours, 1 hour. And they're all equally dissatisfied right now with their personal social network. They have no interaction. So after some exponential random time, one of these 3 will look out into their network and create a new. In this case, let's say it randomly happens. Little guy 1, and he chooses 5. By the way, that's in my current simulation. It's random choice. Okay, so they make a tie with each other, and they sort of compromise on the amount of time they're going to spend together. So the introvert, basically only wants 1 hour of social time. The 5 wants 5 hours of social time. And in the simulation as it stands right now, they just choose something uniformly at random. So they choose to spend 3.5 hours per week together. And now there's a standing obligation for these 2 individuals to always be spending this. And you can already see that the introvert is over-socialized in this instance and will be sort of pressured to dissolve. So okay, let's assume that 5 isn't satisfied. They're the next to make an action to change their network, and they reach out to make a new friend. They still need an hour and a half of social interaction. There's only 1 person available, so they connect with 2. Again, they make some compromise between 2 and 1.5, 1.75, and so, etc. So now 1 is feeling over socialized, breaks the tie. 1 still needs some friends, reaches out to 2. 2 only needs 0.25. So anyways, I hope it's somewhat clear what's going on. And this is all, as I've sort of indicated, this is all happening through time. So this is like the nitty-gritty specifics of what's happening. I basically take the percent of, can you see my mouse, by the way? I take the percent of extra time that they need. So this actually isn't percent, this is proportion. That's a typo. So this person, if you need 50% more social interaction, then your mean time to act, I ended up picking this 0.2 value, is about 10 time units. And then the distribution of the actual time to an action is exponential. So this is what an exponential with an expected value of 5 time units. You see it sort of has a long tail. And we can talk more about this if you have questions. It's memoryless, has some nice properties, but much. So, okay, we've got, say, 30 people. The sizes of the nodes here represent how much social interaction they would ideally have. And we can sort of start playing this forward in time. This is right at the beginning of the friendship formation process, and you can see ties being formed and dissolved. It's just looping here between 0 and 2. I think weeks is probably a good time unit to throw on this, just intuitively speaking from playing around with this. So this is 2 weeks of people with literally no friends, but they want to have friends, trying to figure out how to negotiate this inner, latent extra. And we can sort of zoom out in terms of time. So this is the same network, but sort of progressing faster. And now we're going over the course of 12 weeks. We start to see some more stable friendship ties forming where the configuration is such that they're not really impelled to change anytime soon. And this is speeding up over the course of 2 years, what would happen in this same sort of arrangement. And we see some ties literally stay around for the majority of those 2 years, while some people are constantly shifting around in this structure, trying an optimal load of friends. I'll just keep going. So here's 300 nodes in the same process over the course of 2 years, sort of interacting and trying to find some balance on the individual level, remember. So each of these individuals are trying to figure out some relationships which would either help or, cutting relationship, hindering them having, optimal extrovert. Okay, so what's the point? If we look at the percentage of people who are lonely over time in this network, the percentage of people who have less than 50% of the amount of time that they want to spend, actually they're spending with other people. This is what it looks like over those 100 time units. Okay, and what's happening here? Okay, people are becoming much less lonely at the very beginning. Actually, like in the first time step, it drops by like 40%. And then around 50 here, around a year in my simulation, it stabilizes and sort of drops and rises and drops and rises right around 7. By the way, this dark black line is a single run of the simulation, and the gray lines in the background are 10 more runs of configuration, the same assumptions. And so a couple things, there's a steady state, and also it never really drops to 0. This network never optimizes itself, at least not on this time scale. So it just sort of hovers around 5%. And we can look at the other direction. So these are the percent of the population that are over-socialized. They have more than 150%. The time that they're spending with their ego net is more than 1.5 times what they would prefer. And again, this is, it rises steeply at the beginning as people start making friends and overcommitting themselves, but it never really drops below 10% in any of these simulation runs. So even though a lot of the things up till now have been very arbitrary and contrived, these are sort of uniformities that look interesting and sort of unexpected. So how can we, even though we're not really sure, there's a lot of complexity going on under the scenes, I guess my next question, which I'm not going to be able to answer in this presentation, is how do we get from this to an actual theoretical? So maybe I'll just let that seed in your heads for a little bit, but I can show you some more stuff about this network, about this specific set of simulations. So this is a really cool graph I actually made this morning. Another thing about this is the software is really easy to make new observations of this simulation. Okay, on the y-axis, each of these little rows is a single person in the network. So there's 300 people in the network, 300 rows in this plot. And time goes from left to right. And what we're plotting here is the expected time to take the act of ending a friendship because of over-socialization. So it goes from 2, which I said is sort of a minimum, to 10, and really it goes above, but I've capped it. And in blue, you see the periods of over-socialization in people's. And likewise on the bottom, these are the time until the expected time until you go out and make a friend, make that action to look into your. And again, well, I mean, there's a few different things. So this is like loneliness. The blue is indicating loneliness, and we see it sort of uniformly distributed over people. By the way, the top is the least extroverted person, and the bottom is the most extroverted person, and we really don't see much difference in terms. Okay, and we could start looking at what. Anyways, I'll let you drive what's next and more questions. And I'll just try to wrap up so I can get some questions in. What do I want to do now? What do I have in my mind? First of all, let's just poke at this definition of extroversion. Why is it the amount of time? Why isn't it the number of people that you interact with, or the number of different types of people, or something else? Different distributions of extroversion in the population. In this simulation, I had a uniform distribution from you want a half an hour to 2.5 hours. And maybe instead we want a group of introverts and a group of extroverts, and to have some different proportion of those two types and see what that does to these same output measures. I could add all kinds of stuff in that I really want to do all of these, and I think it's going to be interesting to add this into the simulation. And basically with the question, like, what stays stable as I change the methods of interaction? Like, how much can I wiggle all of these extra assumptions and some output, some regularity that's coming out of my simulation stay stable? I can do things over time, so I can wait for the network to stabilize, and then I can add 100 new people and see how those new people are integrated into the society and how quickly does. And I also want to open source the whole thing and make apps and all kinds of other stuff. So that's it. I guess I'll open it up for questions.
Oh, thank you, Alec, very much. Now, Gianluca. Okay.
Yeah, I unmute. Thank you, Alex, for the presentation. I have two questions here. One from Kieran. Is there some simple way that you could account for multi-person socializing? And another question by Seva, who said, do actors have strict threshold, or they are okay with some SD? What about change in desires over?
These are all great questions. I think these are things I can definitely perturb. In the last slide on next steps, I was talking about social foci. I can imagine that instead of the act that you're propelled to do being going out and finding a random person that has, is looking for another friend, it could be I go to a bar, or I go find a club, or I join a club. And these relations to other sort of entities, it's pretty easy to add this into the simulation, and it's definitely something I want to see how that affects these sort of things. Really, we could have them, we have some propensity to act at any moment, and then the action can be just arbitrary. It can be anything. Maybe they go and ruin another person's relationship for some reason. And the other question about strict threshold, like, do they eventually become content? Is that the idea? Like, I think I missed what.
The second one, the second question.
Okay, I see that. Oh, social discomfort, maybe, SD? I don't know. Yeah, they are okay with some social discomfort, if that's what that means. But they'll always have a little bit of an inkling. In my simulation, they're always going to be a little bit off, so they'll have a little bit of a force to change. But eventually, the T, this time until you make a friend, this eventually goes off into.
Okay, so there is lots of questions. One question by Andreas Flake. Who thank you for the presentation, and he asked if you have tried, or if you are interested in comparing the emergent structures to a benchmark optimal structure, minimizing call data set in mind, or something that you can use for.
Yeah, I can answer that real quick. So I don't think there's any obvious way, given the problem definition, to find an optimal. A configuration of ties which balances all of these people. In the case that everybody has the same preference, then they can just pair off and they'll be okay. Like, each person just picks one other person and spends 5 hours with that person, and that person also wants to spend 5 hours with you, so they all pair off, and it's a degenerate sort of. But in general, if you have some heterogeneity in preference for, I don't know any way to find that solution. And I was actually hoping that this social, individual nodes trying to find, that this would be how you would get to this. And it may be that there is, that the optimal is above 0, right? That people can't optimize this all.
Perhaps one idea could be to find some data related to happiness. I'm sure you can find some data set happiness. There's a huge literature on this. Try to find some data about happiness and friendship or something like that, and probably you can find something in this literature. There are more questions, Federico. I don't know if we have time.
I'm afraid we don't.
Okay.
Keep the schedule very tightly. So thank you very much, Alec, and I welcome our next presenter, who is Karo Itakac from the Institute for Analytical Sociology at the Linköping University in Sweden. Karo, the floor is yours.
Thank you very much, and welcome everyone. So this is a joint work together with Dorottya Kisfalusi, and our problem as that applies for several disadvantaged groups is that they are receiving lower scores, lower grades, and actually I have a problem with this screen sharing now. It seems. I'm sorry. Yeah, let's try. I stop sharing and I retry. Okay, so now I hope it's okay. So this is the title side, and what we experience is that lot of disadvantaged groups, for instance, Roma in Hungary. That's the example that we will have in our presentation. They have lower grades in school. They have lower test scores and blind test scores when they have not the teacher evaluates their writing, but somebody who is not aware of who is writing the test. So and there is even a gap between these two. So the gap between the grades is larger than the gap between the blind test scores. So basically, there might be something more that is causing some problems for these disadvantaged groups. So in fact, this might be discrimination by the teacher that is coming from shared stereotypes in the society, that comes also from certain prejudices, and this also might be the case that there are certain disadvantages that are accumulated. So basically, there's a lot of non-sociological explanation for this. That there are linguistic differences that are coming out only for grades. So, for instance, a verbal achievement is evaluated by the teacher, and there might be differences with regard to behavior that is perceived by the teacher that is not really part of the blind test score, and that explains why the grades, the differences, the gap in grades is larger than the gap in the blind test scores. So basically, there are a lot of sociological explanations that can explain this.